In this talk, I'm going to present coarsening, a new way to do differentiable programming developed by Facebook, and explain how this method speeds up differentiable programming by more than 100 times. First, what is differentiable programming? It is essentially a generalized way to inject intelligence into modern software. We know that when training a deep neural network, there is a forward path from input to output. It is also called the primal path. There is also a backward path which computes the gradients of the DNN parameters so that the parameters can be adjusted through gradient descent. Note that the DNN is essentially just a parametric function, and there is no reason why such a training process can be applied only to DNN. If we replace the DNN with another parametric function like this one, which computes the energy of a hooking spring system, using the same gradient descent, we can make the code automatically evolve, such that the locations of the spring vertices can be automatically adjusted, and hence get such a simulation result. There is, however, one key difference. For DNN, programmers don't need to write code to compute the gradients because the code is provided in DNN libraries already. But that's not the case when we allow arbitrary functions to be used as the parametric function. How to get the gradients in such a general case? Ask the programmers to write code to calculate gradients. It's not so easy to do for such a program with while loops and break statements inside. It would be even worse if the primal code is 10 pages long as this code has. Manually writing code to compute gradients becomes impractical. This is the key barrier to realizing the future intelligent software, also called Software 2.0. Differentiable programming comes to rescue. Its goal is to enable automatic differentiation. With a differentiable programming language, programmers need to write only the primal code. The gradients will be computed automatically through simple AD calls. Coarsening introduces a new way to do AD. It enables a combination of algorithmic differentiation and symbolic differentiation, getting the best of both worlds. It does it by contributing two innovations, phi calculus and reuse-aware SOI identification, which address three long-standing obstacles for symbolic differentiation. Coarsening improves the existing differentiable programming tools' performance significantly. The speedups on 4 AD tools range from 8 times to 335 times. For details, please come to our talk or read our paper.